Okay, so let's do our first example of a linear programming problem. These do take several steps and there's a lot of information to keep organized. So I recommend when you're doing your homework and your quizzes to do in this order that I do these problems in this order. Give yourself a chart if you need to set up your equations and inequalities and follow along finding all these things step by step. On your test, on your exam, I will provide some structure for you on the scratch work that I want you to follow so that again I can see all of your work and award you points for the parts that you get correct. Okay, in this example, Kane Manufacturing has a division that produces two models of fireplace grates, Model A and Model B. Producing each model grate A requires 3 pounds of cast iron and 6 minutes of labor. Producing each model B grate requires 4 pounds of cast iron and 3 minutes of labor. The profit for each model A grate is $2, and the profit for each model B grate is $1.50. If 1,000 pounds of cast iron and 20 hours or 1,200 minutes of labor are available for the production of gates per day, how many grates of each model should they produce per day in order to help maximize the profits? So that's how we know this is a linear programming problem. We are specifically trying to maximize profit in this case. And we are constrained by the amount of cast iron and the amount of labor hours or minutes that we have during the day. Okay, so to set up our constraints are going to be the iron and the labor, and our profit is our objective, right? That's what we want to max or min. So let's see, we're letting A be defined by X and B be defined by Y so that we can graph it on a coordinate axis. So we have each model A grate requires 3 pounds of cast iron and 6 minutes of labor. So if we're looking at model A, we would have 3x here. And how much labor? 6x. They both get x's because they're both dealing with model A. Producing each model B grate requires 4 pounds of cast iron and 3 minutes of labor. So these are going to have y's. So 4 and 3. And we have some totals. We know that there are 1,000 pounds of cast iron available. So the total for iron is 1,000. And the total of minutes of labor is 1,200. And then let's see, for profit, they make $2 for each model A grade, so $2 for each one of these, and $1.50 for each one of these. And notice there is no total here because we're trying to figure out what is the largest total that we could possibly come up with based on these constraints. Okay, so from here, we're going to go down and we're going to look at our constraint equations. So our equations in this, or inequalities really, are going to be that 3x plus 4y has to be less than or equal to 1,000, right? They don't have to use all 1,000 pounds, but that's the most that they could use. And same with labor. We've got that 6x plus 3y has to be less than or equal to 1,200. They don't have to use all labor hours, but that's the max that they can use. Find your intercepts for each one of these because we have to get these constraints graphed. If I put in a 0 for the x here, then I get 250 for the y, and you can pause this and do this on your own calculator if you need to. And if we put in a 0 for the y, you should get 333 and a third, or 0.3 repeating, for the x. I'm also going to go ahead and, as I'm doing this, do my checkpoint before I go over to my graph because I'm going to need to figure out where to shade. I need to leave that blank for a second because I need to get my line on there to make sure 0, 0 is available for me. So let's go ahead and skip down and let's look for the intercepts of the other constraint. If we let x be 0, y will be 400 in this case. And if we let y be 0, x will be 200 in this case. And then we're going to need to check a point here as well, but let's go ahead and we'll graph it first. And then as a reminder, what is our objective function? Our objective is profit. So P equals 2x plus 1.5y. That's why what we're trying to maximize. So I'm going to come over to my coordinate axis. You're going to have to draw these for yourself when you're doing them. But again, on the exam, I'm going to try to give you something to sort of go by. So we've got model A grades over here, and these are actually, it got deleted off of here, but number of model B grades goes on this side. Those are my Y's. So let's see, the point where X is 0, Y is 250, so that would be like right here in the center. Looks like they're counting by 20s. This is 250. And 333, so this would be 320, and this would be 340. So 333 and a third is approximately here. And that is a solid line. If you're drawing these on your own, I definitely recommend getting a straight edge. Okay, so 0, 0 is not on that. So we can check the point 0, 0. If we put in 0, we get that 0 is less than or equal to 1,000, so that works. So we're going to shade below this line. Now for our other one, we're going to graph, I'm going to go ahead and change this one to red. On this one, I'm going to graph 0, 400, and 200, 0. And I'm going to connect that as straight as I can. It's hard that I'm using a tablet. Okay, and if I check the point 0, 0, which is available again on this one, it works. So we're going to shade the side with 0, 0 on this one as well. So I can now see my feasible region. My feasible region is this region here. So it's a bounded region. It's going to have both a max and a min. So again, this profit, I can have a max profit and a min profit according to my theorems. So the next thing that I have to do is I know that the max, which is what we're looking for, occurs at one of these corner points to this region. So it either occurs here, 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 or here. Those are the 4 points. I'll make those a little more obvious actually. Okay, so those are my 4 corner points. Usually most of them are easy ones because they're some of the intercepts that you've already found, but usually there's at least 1 or 2 that you haven't found yet. So I can come down here and I can say, okay, so I know some of my corner points already. One of them is 0 to 50. Make this a little bit smaller. It's really... Another one is 0, 0. Another one is 200, 0. But there's this 4th one right here that I don't know what that is. I can guess based on my graph, but if you don't draw your lines perfectly, then you may be tricking yourself by just looking at it. So I'll give you an area for an intersection point. We need to find this point. So we have to figure out what is the intersection point between these two lines that we were working on. The 2 lines that we had were 3x plus 4y equaling 100 and 6x plus 1,000 equaling 1,200. So what you need to do is you need to go back to stuff that we've already learned and say, okay, I need to find the intersection point between these two. So I'll fall back on some old methods. I'm going to multiply this by -2 and do this by the addition method. That would give me -6x minus 8y equals -2,000. This one stays the same. If I add those together, I get negative 5y equals negative 800. Dividing by negative 5, I get y equals 160. Then if I sub that back into one of these, so let's say I sub it back into the top one, 3 times x plus 4 times 160 equals 1,000. I would have 3x plus 640 equals 1,000. 3x equals, subtracting, I would get 360. So x would be 120. So this intersection point is the point 120, 160. And this should look mostly right. That looks right based on where it was. So I'm feeling good about that. Okay, so now what you want to do is you want to evaluate this objective function at each one of these corner points. So if we put in 2 times 0 plus 1.5 times 250, evaluate that out, you'll get that the profit at that point is $375. Of course, if we put in zeros in both places, then our profit is 0. That's definitely not the max. If we put in 200 and 0, then we get a $400 profit. So that's the best so far. So far, this is the max. One more point to try. This one actually ends up being the best. That's the max. So for my final solution, I'm going to say something like, they should make 120 Model A's and 160 Model B's for a max profit of $480. Notice that the minimum was also found at one of these corner points. The minimum would clearly be $0 in this case. That would be the lowest profit. Sometimes you're interested in minimizing, but in the case of profit, we're definitely interested in maximizing there.